Welcome to the IpX True North Podcast, where we connect people, processes, and tools.
Welcome back, everyone. This is Joe Anderson with another True North podcast. I'm joined by Martin and Martijn again. We're continuing our discussion on the future ecosystems of industry. And that could really be, and as you know, if you've been listening, and if you haven't tuned in before, I do recommend going back and listening to some of our podcasts. They've been excellent. This doesn't just focus on large, corporate OEMs. We're also touching on startups, the small, medium-sized businesses, the whole spectrum in our discussions. And really trying to dial in on what organizations and businesses should be looking at over the next 3 years, over the next 6 years, 9 years. And today, I have to be honest, I didn't warn Martijn or Martin what I was going to talk about. And the last podcast, we really focused in and dialed in a lot on baselines and what that means and organizational change. And we started touching on that. But today, last night, before I fell asleep and this morning when I woke up, I was reading as I always do and doing a bit of research. And there's just a lot out there on the digital thread. And I think everyone's touched on this. And there's a lot out there on the digital twin. And I'm saying that with a smile because I know where I'm going. And then there's a lot of people, quite honestly, and, I don't know that we'll edit this out or not, but Martin and Martijn, I fell asleep pissed off and I woke up pissed off because there's a lot of information out there that's just a copy and paste. And normally I don't go out and do any big CM2 pushes for this podcast, but there's a lot of information out there from other consultancies that are basically copy and pasting our CM2 IP, and it kind of pissed me off. And normally I just we have to deal with these things in the shadows, but I really want to talk about this today because I feel like for our listeners that don't know Martijn or Martin, I'm in rare company. As you also know, I've been talking to Dr. Nathan Hartman from Purdue about the same topic, and we're going to work on getting all of us together on site. We have some fun things planned and some thoughts on that. But what I want to do today is really, from your perspective, break down what the digital thread is first, from a product side, from a process side, from a business ecosystem side. And from my perspective, why CM2 is the actual model, not just a standard, but the model for ensuring your digital thread. And I'm going to leave out from my little 5-minute ramble here my context of what a digital thread is. I know you two will touch on it, but I want to talk about, from your perspective, why the CM2 model really is the basis of ensuring you have a proper product digital thread, you have a proper process digital thread, and CM2 actually, and we know this, at least the three of us and most of our listeners, I hope, understand that a digital thread for an organization is all the requirements, application, environment, export control, everything related, all those touch points that get typically forgotten or thought about at the last moment, serviceability, decommission. When we talk about digital thread in a public scenario, typically it's focused just on product. So what I want to do, and I know I'm not going to speak much after this, which is great. I really want you two to help carve out what the digital thread really is and how the CM2 model is a framework for that and why it's so important, because I think a lot of individuals are getting wrong information from people that just really don't know the authority or don't really have the background to really help an organization improve. And that's dangerous. We all know that. We just saw. Normally, I don't drop name drop issues that are going on in the market, but there's as of today, as of yesterday, we're still seeing Takata airbags exploding in vehicles and injuring and or taking the lives of individuals driving cars. And I'm sorry, but that's not only a design issue, that's a configuration management issue, that's a requirements management issue, that's an application management issue. And at the end of the day, it's my perspective that had they been following CM2, none of this would have happened. And to me, we've talked about it. Martijn, you have a beautiful blog about it's all this just being kind of factored in, to the warranty cost almost. But anyway, I've spoken long enough. I'm going to open it up to you two. Thank you for joining again. I really appreciate this time, but I really just want to hear from you on what the digital thread is and why it's so important to get it right.
I think people that know CM2 know that CM2 is about linkages, and more linkages. And I think that's also what the digital thread is about. It's about linking all the dots, connecting the dots, and not just between information about products, but also information about products and ownership, and therefore to processes and facilities. And therefore you basically get a complete view of everything that is relevant for your business. And that enables you to do proper change management. That enables you to also be able to trace information back and forth. And then in your example of the airbags, even if things would still go wrong, I mean, we don't live in a perfect world. Even if you do CM2 very well, then probably you still have some mistakes down the line. But it is also about how fast can you then fix your problem? How fast can you trace then all the vehicles affected and find where they are and basically get them off the road so that they don't kill any more people? And I think mistakes will be made, that's inevitable. But it is also how fast can you fix your mistake and make sure that, especially in a safety-related incident, how can we ensure that it doesn't happen anymore? I mean, the ignition switches in the past, I think, were also a great example of how things really went sideways, with a lot of deaths in the wake of it. But it's all about how fast can you fix things. And if you connect information, not just about your product, but also about the people, about the process, about your facilities, about everything that is out there, then you have a digital thread.
Yeah, so the interesting thing, always when I hear the digital thread is like, yeah, it is something new. And then I'll go back when I started working, and there was still a lot of on paper. So our project plan was this paper thing standing somewhere, and I was working in the defense industry, and we did all our change requests on paper, and then we got an auditor in, and he always knew exactly which CR was not in our files anymore. It's kind of interesting. But that was basically, we created a whole thread of information. It was all paper-based, but we already had it. So the thread was already there. It's not something new. Suddenly now it's digital thread. Oh, something new. It's not new. I think some companies were capable of dealing with these things in the paper age better than they are now in the digital age, which is kind of interesting because digital should make it easier. And in fact, it didn't make it easier for a lot of them, because I think first, in a paper age, you're very, very keen on which information is relevant. Which information do I have? You have the storage problem and finding it back. That was a pain in the ass, of course. But you knew exactly the information you wanted. Now, digital world came in. We started to, hoard information. And then, okay, now it's digital. Now we link everything. Now we call it a digital thread, and our problem is solved. The problem is, I think, the focus of the problem changed.
I think it was also to do with the fact that the granularity of the information has become different because it became digital. And therefore, you needed a lot more linkages to manage all that information. And if you are not careful and you don't manage those linkages and define those linkages properly, you get inconsistencies. And that can then basically devalue the information that you have linked. Yeah, in the past, we had really clear definitions of what should be in a specific type of document. I mean, Philips had a whole TPD, technical product documentation standard, with all kinds of numbering schemes and essentially exactly what should be in those type of documents. So it was very clear what information is where, and therefore, if you have one link, then that document is linked. Now that document is being translated in all kinds of nitty-gritty objects with tiny bits of information, and now you have to make sure that all that information is connected properly and manage that.
Yeah, so the question is so yes, I agree, and no, I don't. Interesting.
Surprise there.
Yeah, so I recognize the part that we tend to we put more information. So we create more information. We want more detailed information because we want to increase our development speeds, and we want to deliver faster to the market and more variation. True, all true. But I also see is that I think part of the issue is the quality part of so TPD existed, technical product documentation existed in the Philips in the paper age, is still existing in the digital age. Suddenly it looks like we have more issues in what should be in it, what shouldn't be in it. So the way we handle information and the way how we define what should be in certain sets of information, if that starts to fade because it's easy to create information. I think it's easier to create information than it used to be. Digital helps a lot. But that doesn't solve part of the problem. So it created another problem, which suddenly now digital thread is the solution. And of course, I think it's the requirement is as old as we started to write down product information and writing down our processes. I think the requirement is the same. The solutioning and the problem is start focusing because especially what you say, Martijn, more detailed information. We start linking more information. And I think partly because we think the more information we have and the more we link, the more we know. And I think that is part of the problem with a digital thread. What I see in most discussions is that we start focusing on all the information we have to link it, and then we have a complete digital thread. I think part of the thing you also need to do is look at what information do you actually need? What is information that needs to be created? What is information that needs to be stored? So it's a twofold thing. The digital thread or the thread is important. Of course, it's important. If you don't have it, you can't learn. If you don't have it, you can't figure out where your stuff is. If you have issues, you can't find it back. It's vital. It's vital to have that information. Otherwise, you're basically you're incapable of learning, and you're incapable of controlling everything you put down in the world. That will remain there. It will always remain there. Digitalization can help. It makes it easier. It makes accessing information easier. It's easier to create, to follow these threads from where do I start to where do I finish. But just the digital part of it, that's basically what I hate a bit about the digital thread. The focus became digital instead of thread, which for me is way more important. It's a thread of information. And the fact that it's digitally stored can help you, but it's not digital is the solution, and the thread is basically, that's the part that comes out of it. I think if you have that mindset, you will always run after the facts.
I think also what is lacking oftentimes is that what you mentioned, what information is relevant to have part of your digital thread is all the information that somehow will be consumed in some other process, right? So somebody creates something and then somebody else down the line is going to consume that information to do something with it. If that information is not consumed or only part of it is consumed, you basically over-documented information, which can also lead confusion. And I think it's very important that therefore a digital thread is not only about looking at what product information, for instance, you need or have, but it's always tied to the processes, to your business in that sense, and the needs of the people in those processes, in that value chain, to help them with their next steps. And by definition, having more information in is not necessarily a good thing.
Oh.
Yeah, so I was hoping this conversation would head this direction and really focus in on the thread or the network, the linkages, whatever you want to call it, but it's all those touch points, and you both are discussing it. The thread is that's kind of that hidden gem of an organization, right? If it's really identified, set up correctly, and this is I'm kind of a slow pitch, so to say, for the next topic. We've got to identify it. Let's just take a product, for example. Martijn, as you stated, there could still be issues in the field, even with a company that's getting it 95% right. Let's say they've got a proper way of identifying all linkages. They have a proper way of communicating all those linkages. They have a proper way of managing change to all those linkages, from ideation all the way to logistics and serviceability, right? So we've designed it, we've manufactured it, we've shipped it, installed it, we service it, information gets sent back, we manage change to that thread now. But there could still be part failures, because the one area organizations are struggling with the thread is our supply chain touch points. And, it goes back to the, I don't know a better cliche analogy. You're only as strong as your weakest link. And that still rings true when we're talking about the thread across our supply chain. And with that, what are you seeing in your experience? What's happening today in the supply chain? Do you see a shift? Do you see organizations starting to work together better, trying to get their tier 1, tier 2, and tier 3s to the level of where maybe the OEM is, from a process, from a thread perspective, from a digital thread perspective? And what kind of issues, do can happen when those tier 1, tier 2, and tier 3s don't have proper control of that information, of those linkages?
But the last is the easiest one. If you work with a supplier and you basically order parts from your supplier and you think you know what you're getting, then basically you don't know what you're getting. So from that moment onwards, you're blind for that part of your product. And that could be a very small part. So for a car manufacturer with that airbag in it, they're basically blind for what comes in. And they assume, and that's the wrong word, of course, they assume that they get what they think they're going to get. There is a part number on it, and it should be identified what it is. Now, of course, if your processes together with your supplier are not really linked up properly or matched with each other, then you will get those interesting things. Is that you're asking for changes and you don't get them at the moment you expect them. Maybe the part numbering is incorrect. Maybe you agree to do something under the part number and it's not visible on what level. You're blind. So your question, and I think Martijn can say more about it, but if your two difficulties, I guess, your supplier is less mature than you are, that basically means is that for that part in your machine, your CM is broken, or at least it's hampered. Could also be the other way around, which is, I guess, just as worse if you don't understand that your supplier is better in configuration management than you are. I think then you will have the same confusion. Maybe your supplier doesn't have a real problem, but most likely you will get into issues with your supplier because you think that you found something that is incorrect, because your systems basically tell you it's in that area, while your supplier knows it isn't there, which still is as bad as the other way around, I guess. So for me, it's like the weakest link. Of course, the weakest link is what basically determines what your maturity is and what your maturity level is.
But even if let's assume you have your maturity of CM is great. Your supplier first tier is CM is great. Second tier, third tier, all is great. All great CM. Even if, let's say, that third tier supplier is going to make a change and he makes that announcement, currently the time that it takes for that announcement to trickle through that supply chain, reach the OEM, and the OEM to have time to react on it, that's too long already. You've already lost valuable time. And there currently are vendors that are trying to bridge that gap a little bit by having a kind of a collaboration space where you can work together with your entire supply chain on exchanging information, so to run things faster. But it is critical that even if your CM is perfect, timing is also essential. So the moment you need information is the moment that information is created, not a month later. And then it still takes you at least a month or longer, depending on the type of change you need to do, to process the change. That could be already too late to deal with the supply chain change that's coming up.
Yeah, but then put it the other way around. If you basically said, if you are perfect in CM, then it will take too long. But now turn it the other way around. So what I now see, and you already said it, is collaboration area between the suppliers, and maybe this whole confederated PLM over the whole world. How nice would that be? All information available for everybody. You just plug into the PLM system and you can see all the information. Oh boy, if then you're not perfect in CM, that basically means is that incorrect information will even flow faster through everything. So the impact then changes.
Your garbage will be out there.
Yeah, the garbage will go way faster than it should be. So, again, this is kind of interesting. I think it's the same with the digital thread. As soon as you start digitizing, as soon as you start opening up information, the more immature you are in CM, the more vulnerable you are for high impact problems.
Yeah, and I think you two are also bringing up some very, very good points about the thread, right? And the linkages. So let's say, like we're discussing, we have proper management of that data and all those linkages and touch points. There's inputs and outputs, and they're not just data. And this is one area that in our world with our clients and our partners, there's a need for these organizations to figure out the inputs and outputs as far as communication and collaboration. And how do you think organizations should look at improving the way that they communicate and collaborate internally and externally? So we all know, at least most companies, I haven't seen a perfect one yet, that there's still a struggle, a kind of siloed mentality of this functional expertise. There's engineering, there's manufacturing, there's quality, there's sales, there's marketing at times, and branding, and sometimes everyone gets brought in too late or too early, which both of you touched on. But how can we improve that internally? But and it's the same with our suppliers. We've got to figure out, even if we have all this information, even if we have this utopian PLM system that has all the information and has all the proper security protocols for who could see what and who can know what's there, right? We all know from a global perspective what that means from export control and ITAR. But also how can we improve collaboration internally across our functional expertise? And we know some of that within the CM2 world, but how do we do that across that whole supply chain ecosystem? So my question to you two, I went way too long there, I pontificated is, so let's say we figure out how to manage the thread of linkages and information and data properly. Now, how can we improve the way we communicate and collaborate?
You need to speak the same language. I mean, one of the biggest problems, of course, everybody still understands what a part is, but then it starts, right? What kind of information are you sharing? Are we talking about the same thing? Take, for example, if you're sharing 3D information, in what format are you going to share that information? What are the agreements? Depending on the suppliers that are providing, you might have to have different kinds of formats, different kind of sets of information that you need to share, or you can prescribe it because you're the big guy in the crowd. So you basically are deciding how to organize that.
And also, what level of detail do you put in your 3D model? So you have 3D models and 3D models. If you supply a different level of granularity to your supplier, then because internally you know how to deal with this, but your supplier doesn't know, and still you're talking about a 3D model, but you're talking about something completely different.
Can you two talk about that a little bit? What do you define as a 3D model? Can you let's break that down a little bit within this context.
Yeah, so that I think it's at least the geometry, of course, of a part or an assembly or whatever you want to call it. But it can, of course, include other information like PMI, product manufacturing information. I think the biggest problem that I see is that you have different requirements, needs for 3D models. So, for instance, especially in businesses that have like doing installs at customers, big machines, or Therefore, the environment in which those machines end up, like for instance, also medical devices in a hospital, it's also a good example. They are coming inside a certain environment, and all those environments are not identical. The question is, what information do you need for that customer to be able to receive and prepare that environment to be able to receive that product of yours? Is that the same kind of information, or do you have kind of only the outer shells that you need? So then, are you then talking about a different 3D model or a filtering of a 3D model that you have for your product? So all kinds of different requirements come in, and the question is, what are we talking about? What are the needs? And I think it's not always as simple, because if you look at a lot of PLM systems, how you can edit the information, how you can change the information, it's typically done by engineers, but the people that are responsible maybe for the installation might have different requirements, want to add different additional information, properties to it than from a production perspective. So how are you going to deal with it? Are you going to separate the models? Are you going to put everything in one model? I don't have a magic answer here, but these are struggles that you have, but they will also have an impact on how you can communicate with your supply chain and with your customer base, because it's in both directions, right? It's not just your supply chain that you have to talk to. You also have to, in this case, talk to your customers, because they have to prepare the environment that they will receive those products in.
I'm not a 3D engineer. I'm coming from the software world. So I'm most likely, if a 3D engineer is listening to me, he will tell me that I don't understand it. But for me, a 3D model is nothing more and nothing less than a structure to which information is linked. And this structure can be shown in a tool in a 3D way. And you can manipulate it. But for me, it's still a structure where data is linked to it. And I think one of the issues is that in a lot of the tools, the implementation isn't in this line. So it became a model, a big blob. And now suddenly it becomes very difficult to manage and to handle. And then you get the questions about filtering and etc., which in a classical bill of material, and I'm not stating that we should use that 3D models, we shouldn't use them and bombs are the most important one, because that's absolutely not my statement. But in a bill of material, most tools have these filtering mechanisms and etc. So there we have a structure, we have linked information, and we know how to edit that structure. In a 3D world, I guess, although it is a very, very powerful environment, the way it's implemented in tools, and some of the tools were created 20, 25 years ago, I think the way it was set up in the past, it doesn't help if you look from a configuration management point of view.
There are tools now, though, that are a little bit more advanced, right? So that it's more like the 3D modeling becomes like software development, but then for 3D. That you actually can create branches, and you can merge to your main, and you can have every action you do is like an event or an object in that model, and you can remove or reposition everything, or you can say I only want to copy this to my next model, and the rest I forget about it, or you can create multiple branches. So those are the things that are possible nowadays in those little bit more modern tools with modern capabilities. But I agree, in still a lot of other 3D modeling tools, you're still very classical in that sense, and it's you have just one revision, and you can go to the next revision, and that's it. You're stuck to that way of working.
And an interesting point both of you brought up. Martin, from the structure side of it, and understanding that it's still structure, and then Martijn, from your consumer and your customer base, right? And understanding that there's going to be application requirements, environment requirements. And when we talk about kind of the future and the future capability of why it's so important to get the structure correct, as Martin was raising, and then Martijn understanding the true install and application requirements of your customer. And this is where a lot of companies are still getting it wrong. They have, let's say, they've got perfect install, perfect application, and perfect environment requirements. A lot of organizations aren't actually testing and ensuring quality in that setting. So they manufacture and produce a product, they test it out in their environment, and when they go to install it, things start to happen in the field because this is one area that we're seeing that we also have to create test environments that mimic. It could be virtual or physical, one way or the other. We have to have a test environment that can mimic those environmental requirements. And so from an application standpoint, we see we have a few clients that are really leading the trend on AR serviceability, right? So they have a service tech using AR to really diagnose an issue and figure out how to solve that quickly, as Martijn brought up much earlier, which is we need to be able to root cause an issue in the field, identify it, analyze it, propose a change, get the change implemented, and get that fixed quickly and control that and ensure traceability going forward, right? It's one thing to fix a product, but do we have traceability now once we start compounding those service maintenance schedules? But from my perspective, one area that I see as a major benefit of the digital side of the house is the ability to truly ensure that when we install this, all of those requirements from an install, from an application, from an environment are going to be met. And then we can manage traceability to that as well. So this is another area, as I know both of you are familiar with. We have a organization that decides they're going to move facilities or transfer sites. So they're going to take all of this equipment, take all this functionality, and place it in a new environment and a new application. Again, this is where a lot of organizations waste a lot of money because they don't understand and they don't communicate back to their supplier of, say, that machine that, hey, we're moving this. We're going to move it from location A to location Z. So we're going from a cold environment to a very dry, sandy environment where everything changes. And I think part of the communication and part of the opportunity is we could manage that. And it goes back to traceability, Martijn, from my perspective, across the full ecosystem, and that includes once it's installed, once we now are working with our consumers and our customers to actually have full maintenance and serviceability and have full traceability there, but also linkages back into product development. And I know I said a lot, but do you agree that this is one area that organizations should be looking at with their consumer and their customer base, which is, and we have a lot of clients, and I'm not for sure on ASMLs that, their products are actually, they control the service of it, right? That's kind of the aerospace model for a long time now. But we also need to control and communicate any environmental changes, right? We have OEMs that require their suppliers to communicate that if we're going to change sites or change lines. How do we handle that when we have product in the field, and how can we approve that with the model, but with also communication and collaboration?
I think it's even interesting because I think some of the changes you might not even do yourself, let's put it like that. So let's say due to climate change, the average temperature or the average humidity or whatever is increasing. So therefore, the environmental conditions are changing, not by your choice, but by the fact that there's a climate change going on. And suddenly your products are exposed to situations they were not intended for initially, or not for longer periods of time, for instance. I think it's very difficult to deal with all those situations. I think you can only do so much. But I agree. If you are creating products that are going to different environments, you need to be able to at least simulate that. In these situations, you can't make tests always physically in those situations because you might not have access to it, or it's just too expensive to do everything in a physical environment. But at least simulation, I think, is a very important aspect of figuring out if your products will still behave in the way that you expect them to behave.
And of course, it's interesting. So I think in a business-to-business environment, I think the companies are maybe a bit more aware or are more focused on it, on where are my products going. In business consumer, it's also becoming very interesting, of course, because if you're in a business consumer, don't have this right, the internet will basically tell you that you were wrong. And that basically will mean is that your reputation can be ruined by one product where you basically didn't have this completely under control. guess what? You're too late. But once your reputation is gone, especially in the consumer world, it's very, very difficult to get that back. If you were producing a phone that basically is not that very well working in very low temperatures, guess what? There are a lot of places in the world where it is very, very cold in the winter. You will not sell a lot of your products over there. So you need to be aware of these things. You need to be able to, if it's difficult to design all this upfront, then simulation is something that you will need. And that, of course, is where your digital thread is really, really handy. Also, to figure out what did I simulate, what didn't I simulate, which risks will I be taking, because business is all about taking risks. It's impossible to avoid all the risk, because if another company is willing to take a little bit more risk because they have a better understanding of which risks they are taking, they will take a lot of your market share.
And be aware that if you simulate something, you have to make sure that you simulate the right configuration, the configuration that you're actually selling. Yeah. Because if you simulate something else, then your simulation results might not be very valuable. So therefore, digital thread is critical, right? So it's not just I want to simulate. No, I have to simulate what I'm going to sell. Otherwise, it's still useless.
Yeah. Basically, you didn't reduce your risk if you're simulating something else than you're actually producing.
Yeah, so you might have simulated in the past something, and that resulted in some positive results. But if you therefore apply changes to your product, and therefore your configuration changes, it can influence the simulation results. So you might have to redo all your simulations, and which is a good thing of simulations, because redoing virtual simulations is a lot easier than doing everything physical. So I think that's a positive thing. But it's something you have to manage as well. So, and that's, I think, where also then the threat comes back into the picture.
I think also the pitfall here is that I think if you're not, so maybe in the ideal world, your perfect digital thread with your simulations and everything is okay. Now you want to make a change, you can perfectly see all the impact, etc. The question now becomes is, doesn't that also start hampering you in making changes? Because sometimes it is about risk taking, and maybe this sounds a bit weird, but sometimes because you don't know something, it could be you make the perfect choice.
Ignorance is bliss, right?
Like intuition, and I know it's maybe the wrong path. The idea that you can capture everything and you can reduce all the risk, because that's not true.
No, but I think it's about the balance, right? Because now sometimes I feel that people are just taking risks, just ignoring them, or not looking into them. So doing a risk assessment, even though you already know what you're going to do as a decision, because you're going to go forward with it or whatever, but doing the risk assessment, understanding the risk that you take, allows you to at least define a mitigation strategy for those risks. Just ignoring those risks is not just dangerous for your company, it could also be dangerous for your customers, especially if it's a safety risk is concerned. So I think understanding risk is an important part of making good business decisions. Even though you still go ahead with it, you at least know what you're running into. Otherwise, it's just putting on a blindfold, getting in your car that is full self-drive mode, and you go like, I hope I get home alive.
The interesting thing is, it's you understand this. You understand why you do it. Now, on the other side is this business person that wasn't really trained in CM, doesn't understand what the reasoning is behind what we do, and before you know it, he basically says, "You only start to hamper me. You're trying to slow me down, etc." So this interesting.
But I think that's then a lack of entrepreneurship in people, because to me, everybody should have a little bit of an entrepreneur in them, even if you're just an engineer. Doing business is about taking certain risk, but it also is about understanding the risk you take. And for an engineer or for somebody in the factory, that also means that in their context, they should be aware of the risk they generate downstream.
And that's why I always talk about CM2 as guardrails, and then I try to use the analogy of a funnel, at various stages, let's start at R&D, that those guardrails are out there. There's a lot of opportunity to design and fail fast. But as we get closer to production and manufacturing and shipping and install and service, those guardrails should shrink, right? They should close in on themselves because we want to manage that risk a little tighter. And, as you two were talking and I was looking at the Muppet background of Martijn and myself behind Martin, it really I started thinking about, and this is going to tell my age, I don't know if they exist anymore, but when I was young, they used to have what was called bumper cars at the local carnival, fair, or, at your larger theme parks. And when I was younger, you'd get in a bumper car and there were no rules. The only rule was keep your hands in the car, the vehicle, and try to survive for the next 5 minutes. And then probably a couple of years after, I learned how to survive and, recover from whiplash. Then they implemented rules that, okay, the cars are still in our little bumper car facility, but now you can only go in one direction. All right. That's our new guardrail, because we figured out allowing adults and children to get in these vehicles and just go crazy, a little too much risk. And that's kind of what CM2 is. We start out here for R&D and development and innovation, and we want to bring those in. But if any of you had adult supervisors or guardians, parents, or let's just say a grandfather like I had, no matter what rules were implemented in that bumper car facility, he didn't care, because his objective was to always hit me as hard as he could, and to ensure when I got out of the bumper car that my back hurt. I'm going to stick with
and
that.
by the way, they still exist. Last week, I was in the bumper car with my daughters. But I think it's not only about the guardrails of only one direction. I think it's also about how much speed do you allow these things to go, and how hard, therefore, is the collision, right? The maximum collision, I think. But they're still fun. So,
and I'm guessing they have safety belts now as well.
Yes,
they do. They don't work. They do.
But we're having fun. But the reality is that's what we're talking about, and that's where a lot of companies and individuals go, oh, you're going to slow down my creativity. You're going to slow down innovation. No, just quite honestly, just stop talking for a minute and listen. What we're saying is, we want you to have as much freedom as possible in this innovation realm. You still need guardrails. Why? Because it's great to be able to create something new and evolutionary once, but if you don't track how you did it, you're not going to be able to efficiently make it 1,000 times. And that's, again, where a lot of companies struggle with money and speed of getting innovation out the door, is because their guardrails here weren't set correctly.
I even heard in a podcast, I can't remember from whom, but it was recently, that there was also research that said if you get too much freedom, innovation gets to a halt, because people don't know what to do, because they don't know what to decide upon, because there's so much freedom. Mm-hmm. So also having boundaries in place actually accelerates innovation. So I think it's actually a positive thing to set certain boundaries, even in early stage, because you cannot go in every possible direction and come out at the end with a good answer. You also have to set a kind of a direction already, some boundaries that help you go through that funnel in the end. Because if there's nothing to bring you to that funnel, you don't end up anywhere.
Yeah, and I think also innovation is about learning, and the only way you learn is about writing down what you actually did.
Yeah.
So those guardrails are in the beginning minimum, maybe because of what you're allowed to do, but you still need to write down what you've done, what you're doing, because otherwise you can't learn. And that basically means that you're constantly innovating the same thing, which is a lot of fun for engineers. But from a company perspective, I don't think you're going to survive very long if you keep innovating in the same thing.
Yeah, and we're coming upon closure of this session, and I'm gonna bring it back to the bumper cars with what you two just stated, and it's just a perfect analogy. When I first started riding in them, I was young, and there were no rules. right? The only rules were, like I said, just you can't drive the bumper car out of the facility. Good luck. But it was chaos, right? And with that chaos, in the beginning, people were trying to hit each other. But what happened, much to Martijn's example, real quickly, everybody just got congested and clogged up. So the operator of the bumper car facility and ride had to go out and move the bumper cars again and separate them. And then what happened? No rules. We got congested again. And then someone had to take the time. Okay, we got to clean up our mess again, get it. So these rules, much like, Martin, you were alluding to, is it's getting everyone to understand we're just trying to limit chaos and improve that efficiency to get things out the door, out that funnel. But for me, I'll let you guys kind of wrap it up. But to me, it's a perfect end of this discussion, which is, bumper cars were awesome in a day. I still had back problems, but the reality is, the truth is, the thread's important. Understanding that proper CM, based off of a proper model, which I'm just going to flat out say is CM2, ensures you have the right guardrails. And it's all about making you more efficient and effective. And that's what the digital thread is supposed to be as well. But really, guys, again, another great discussion. Looking forward to the next one. And hopefully we'll start seeing us face-to-face doing some of these. We got some exciting things we're working on here at IpX for the True North podcast. For our listeners, please go back if you haven't and listen to some of these podcasts with Martin and Martijn. They're fantastic. They really are. It's such an honor to join these two. And Martijn also has a blog. Highly recommend our audience to follow Martijn, read his blogs. They're really good. Just a lot of great information. It's a very rare skill set that these two individuals have. So Martijn and Martin, thank you again. I look forward to doing this next week and hopefully face-to-face soon.
Yep. Thank you very much.
Thank you for tuning in today. Don't forget to subscribe and review the show. And for more information on IpX, visit ipxhq.com.